Okay, hello everybody. Welcome to the course. This is a course in iOS 7, creating games for the iPhone using SpriteKit. And my name is Jed, and I'm going to teach you some of this stuff. So let's get started by creating a new SpriteKit template project and seeing what's in there and having a bit of a discussion about that stuff. So just in case you're not really sure, SpriteKit is basically a rendering engine. It takes care of a lot of the boilerplate code so that we don't have to worry about how to draw stuff on screen. And it can also do lots of handy things like moving stuff around for us, animations. It's got a whole bunch of physics features which are pretty cool. So yeah, it's pretty much it lets us concentrate on the gameplay and not have to worry about the annoying side of making games. So let's get started. Here I've got iOS application SpriteKit game selected, and I'm just going to create a new one, SpriteKit demo. We're just going to have a play around with the template project in this video, so probably not going to keep it, but I'm just selecting iPhone for the devices because we just want to concentrate on that one for now. So let's go next there and save that one away. Alright, so here we are. I've just selected the view controller so that we can have a look at some of the code in here. We can see in the viewDidLoad method here that it is setting up a view for us. It's an SK view, SpriteKit view. So the SpriteKit view is a type of view that we need to use whenever we want to display any sort of SpriteKit content. We're going to need one of those guys. And it can be used alongside other views that you're used to using in your iOS application. So that is cool. But also it can display some diagnostic information for us so we can make sure that our game is running smoothly. We can see the frame rate and stuff like that. So that's handy, but we'll discuss some of those features in a later video. And next, here we can see that it's creating a scene. So scenes are things that help you organize your content. So anything in your game is going to be organized into some sort of scene. So you're going to have like your menu that is obviously going to be a scene, and the game itself going to be probably two different scenes for the most part. But yeah, anytime you want to add something that you want to see on screen, you're probably going to add it to a scene or to something that is already contained within a scene. So we will have a look at that in just a moment. But first up, let's run it and see what this template application is doing. Hello world. Okay, that's your standard sort of little first time application. But if I click on here, we can see that a massive spaceship shows up and it rotates around, and I can click and add loads of them, and that's really cool. But let's see how that is happening. So I'm going to jump over to the scene here and have a look at what's in here. So in the init method, we can see straight away that we're setting the background color, and that's where we're getting that nice blue from. So I think that one's pretty self-explanatory. If you want to change the color, you just have to mess with those values, and that's cool. But after that, this is where we're getting the text from. So we're creating here a node. This is what's called a node. This one is an SK label node. So it's a special type of node that displays labels. And we can see that it's setting the text property and the font size and the position and all of that sort of stuff. But let's talk a little bit about nodes. So nodes are really the fundamental building block of anything that you want to add to your game and see on screen. So you're going to create some sort of node. In this case, it's a label node, but we can see down here we're creating a sprite node, which is where the spaceship is coming from. But yeah, nodes Nodes can really contain other nodes as well, so that's an important feature to note of them. So they can have children, and so we can see that that's what is going on in this line here. So we're saying self add child my label. So the label node is being added to the scene. So what that tells us is that the scene itself is also a node, because nodes can contain other nodes. And so SK scene actually inherits from SK node, So SK node being the most basic type of node that you can have. So whenever you want to add anything, you're going to need to add it to some other sort of node. A lot of the time that might be your scene, but at other instances you might want to add it as a child of another node that's in your scene. And the reason you might do that is because you want the child node to be in the coordinate system of the parent node, so that whenever you move that parent node, all of the children move along with it. So that is pretty cool. So yeah, you end up basically having this big tree of nodes, all organized in a certain hierarchy. And we can see that that is what's happening down here as well. So in the touches began event, we can see that first up it gets the location of the touch event, and then it creates a sprite node with an image named spaceship. And we can see over here, this is the spaceship graphic that is in our project. So it's just referring to the file name of that to add that one. And then it's setting the position of the sprite node to the location of the touch. And then we can see here it's doing some funky little stuff using actions. So the action that it's created here is a rotate by angle, and it's rotating it by pi radians every second. And that is, actions are pretty handy. You can sort of use them to do lots of different things. There's loads of different types of actions, and you probably end up using them a little bit, or quite a bit. So let's have a look at sort of creating another action right here, because I think rotating a spaceship is probably a little bit silly, really. Let's create one where the spaceship moves forward. So I'm just gonna comment out that line and create it again using a different type of action. So here, if I start typing move, we can see that there's already a bunch of different move actions that we can create. We can move it by a certain amount to a certain point, but in this case we just want to move it by an X and Y location over a certain amount of time. So we're going to move it, we don't want to move it to the side at all, so I'm going to put 0 in there, but we're going to move it by 200 points forwards or up in our coordinate system over 1 second. So every second it's going to move by 200 points. And if we were to run that action just by itself, it would move by 200 and then it would stop. But we can see here the next line is actually creating another action. So it's saying run action, but the action that we want to run is a repeat forever action of the action that we just created. So we're adding that action to this repeat forever action, which is being run on our sprite. So on the spaceship is running the action before we add the sprite to the scene. So let's run that and have a look at what we've done. So if I click now and have a look, we should see the spaceship flies up, which looks a little bit more sensible than having it spin around. So yeah, that's a pretty simple overview of the template, but I just want to sort of highlight a few things there, talk about nodes, and a little brief look at actions. But we'll get stuck into a lot of that stuff a bit more in the next few videos. So next one I think we'll talk about coordinate systems and stuff like that. So yeah, just have a play around with that if you want, and yeah, thanks for watching. As we progress through this games course, we are going to be creating and working with nodes constantly. And so I thought it would be a good idea at this point to really just go into a little bit more detail about what a node is, because really they are the fundamental building blocks for everything that we want to put into our games. Whenever we want to display something on screen, we're going to be creating some sort of node. So if we look at this template project that we sort of had a look at in the last video, we saw that we encountered 3 different types of nodes. We saw this label node, which was being used to create the hello world text that we saw on the screen. And we also saw a SK sprite node, which was being used to render the spaceship. And then the scene itself is also a node. So both of our label and our spaceship were added as children of the scene. So the scene contained those two nodes. And so all three of these nodes inherit from this base node type, which is called sknode. And so I thought it might be a good idea if we have a bit of a look at Apple's documentation on this sknode class and just get familiar with some of the different properties that we have as part of every node. But we can also see here that Apple has sort of spelled out what different types of specific nodes are available as part of SpriteKit. So we've already encountered the sprite node. We use that if we want to draw some sort of image on the screen. And we can also use a sprite node to draw a colored rectangle, and we'll have a look at that at the end of this video. We've also got a video node here that we could use if we wanted to play some video. I'm not sure how often you might need to do something like that, but it is there. We saw that we could use the label node to draw some text on screen, and so that can be useful to show things like scoring and stuff like that. Shape nodes can be used to draw specific shapes that we base on some sort of graphics path that we create. Emitter nodes are a lot of fun because they allow us to do particle effects and stuff like that. So we'll definitely be having a closer look at those later on in the course. And then these last two crop nodes and effects nodes can be used to affect how their children are drawn. So they don't draw anything themselves, but we can sort of crop a node to a specific shape using some sort of mask, or we can apply different image filter effects to certain nodes. So that's a bit of an overview of what types of nodes are available as part of SpriteKit. But let's have a bit of a closer look at the properties of a node. So to create a node, we can use this class method node to actually get back an instance of a node. But some of the more specific nodes, like the sprite node and the label node, will have their own sort of constructor type methods here that we can use to sort of create a more specific node that's, say, by passing in an image, for instance, with the sprite node. So we'll see some of those as we move along. But in terms of the properties here on a node, ones that we're obviously going to be setting a lot is the position, because if we want to draw anything on screen, we need to say where we want to draw it. We can get information about a node's position and its size by using the frame property there. It's going to take into account what the contents of that node is. We've also got these scale and rotation properties and methods here that we can use on a node, so we can change the node's size and we can rotate it. Alpha and hidden control how a node's drawn. Obviously, if we set it to be hidden, it's not going to draw at all, but the alpha property allows us to set how transparent our node is. If we scroll down a little bit more, I'm just kind of pointing out the things that we're sort of going to be using a lot. We're going to be working within our node tree a lot, so you're going to be seeing add child quite a bit, because whenever we want to add a node to a tree, whether it be to the scene itself or to some child of the scene, we're going to use add child. But we could also insert nodes at particular points in the tree, and then we can remove nodes from the tree. We can find out what children a particular node has and sort of interact with our nodes throughout the tree using these methods and properties there. Naming a node can be quite useful. If you want to find a particular node with a name, we can set its name and then use a child node with a name to get it back. But we could also set a number of nodes to have the same name and then enumerate through all of those nodes and run some sort of code against them. So that can be quite useful. We also saw in the last video that we can run actions against nodes. We saw that we could move our spaceship by either rotating it or moving it forward. So we saw two types of actions there. So we'll probably be doing that quite a bit, because anytime we want to add some sort of movement or animation in our game, actions can be quite handy to get that going. Physics bodies, we'll definitely get stuck into that stuff. if we add a physics body to a node, then it will be picked up by the physics simulator and be moved about as it needs to. So by adding physics bodies, we enable our nodes to be affected by the by SpriteKit's physics simulation. And because each node contains its own coordinate system and all the child nodes of that node sort of work within that system, sometimes we need to convert a point from one coordinate system to another. So we can use these methods to do that. And we can also find out whether a particular point is within a node or find what node is at a point using these methods. So yeah, that's a pretty sort of brief overview, just touching on some of these properties to hopefully flesh out a bit your idea of a node. And these are all just for the basic node type, the SK node. So the other node types that we saw here that inherit from this obviously have all those properties, but they also have their own more specific properties. And we'll get stuck into looking at some of those as we are creating these different types of nodes. But if we jump back into our code here for our template project, let's just go through another example of how we can create a node. So here in the touches began event, when we create the spaceship, I'm going to create another type of node after we've created this spaceship. So it's going to be a sprite node as well, SK sprite node. And I'm going to call this one square. And we can see here that when we create this spaceship, we create it by calling sprite node with image named, and we pass in the name of the image that we want. And so that's going to create a node that draws this particular image on screen for us. But we can also create sprite nodes that just draw a colored rectangle. And so I'm going to do that now by calling sk sprite node with color. And so by passing in a color here, sk color, I'm going to pass in the color red color, and then giving a size, cg size make. I'm going to set it to be 20 by 20. So by doing all that, we will have a node that it doesn't have an image, but it will display a colored rectangle for us. And so we should see a red rectangle on the screen. So in order to actually see this on the screen though, we're going to need to add our sprite to our scene, which is the class we're currently working in. So we could just add this directly to the scene, or we could add it as a child of another node that is already added to the scene. For now though, let's just add it to the scene itself. So I'll say self add child square. And we'll give this a run and see what it looks like. But I do just want to point out that we haven't set a position for our square here. So the default position for the square is going to be 0, 0. So when we create this node, which will happen when we click, our square should appear at the location 0, 0 within the scene. So let's click run here and see what that looks like. So as soon as I click here, we get a spaceship, but we also get this square, and this square comes up down the bottom left hand corner here because this is 0, 0. But I will also point out that we're only seeing a quarter of the square here because our square is actually extending out outside of the bounds of the screen, because the square is positioned so that it is centered on its image. And we can check that out by changing the node that we're adding this square to. So if, instead of saying self here, I say sprite. What we're going to see now is that we're going to add the square to the position 0, 0 within our spaceship. So let's run that and we'll just have a look at what that looks like. Cool, so now we can see that the spaceship and the square are showing up exactly where I click, but also the square is now rotating with the spaceship. And so we can see that the square is inheriting some of the properties of the spaceship because it's working within the spaceship's coordinate system. So it's inheriting the spaceship's location, and it's also inheriting the spaceship's rotation property. And if we were to set other things like alpha and hidden and stuff like that, then that would also be applied to the children of the spaceship. So it is important to note and think about where you're adding your nodes within the tree. So just to highlight the tree that we're working with here, I've created this little illustration of what's going on. So our scene is at the root, and that is of type SK scene. And then we are adding the label node, which we were seeing sort of drawn behind our spaceship. And our spaceship is being drawn over the top of Hello World because it's being added after Hello World. So the order that we add these nodes to the tree is important. And then we also added this square node, but we added that as a child of the spaceship. And so we were inheriting the spaceship's location and rotation properties there that we saw. And so that's just been a bit of a closer look at nodes there. We are going to be working with them all the time when we're creating our games. So it might be worth sort of having a bit of a look through the documentation and just sort of having a bit of a read up and seeing what type of different nodes there are. So I'll include the link for that for this video. But hopefully now you've got a bit of a stronger idea of what a node is. In this video, I'm going to have a really quick look at how we get graphics into our SpriteKit projects. If you're familiar with kind of dragging images into your projects and all of that, then feel free to skip this video. But if you just want a bit of a refresher, we're going to have a quick look at it now. So what I've done is I've downloaded this graphic off of a great website called opengameart.org, which has a lot of free resources for assets for gaming. So it's a good website to check out. But I've downloaded this space graphic and I've kind of sized it for our iPhone screen. And I just want to pull it into the project and get it drawing on the screen. So one thing to also note here is I've put this at 2x on here to make sure that SpriteKit knows that this graphic is designed for a retina size screen so that it won't automatically scale it. So just one thing to keep in mind. But all we have to do, I'm in the Finder now and I've got this graphic. All we have to do to sort of get this into our project is just drag it along here into the project here. And then we're going to get this little window pop up, and we want to say that we copy the items into the destinations group folder because that is going to take a copy of wherever I had that image saved and actually pull it into where all my code and stuff is saved. So I want to make sure that that's copied. And if I was copying a whole folder, then I could do this create groups for any added folders as well, which can be useful to organize your assets in your project. So we also need to make sure that we add it to our target so that SpriteKit knows about the image when it's building the project. So if we just click finish here, we should see that our image shows up here. So it's all ready to go. And so let's just load this image up and put it in our background. So what we can do is in our init with size method here, before we add our hello world label, let's create a new SK Sprite node that uses this graphic that we've just imported and draws it on the screen behind everything else. So let's create an SK Sprite node by just putting that in there and then declaring what we want this node to be called. So we'll say background. And to create an instance of a sprite node, we can use the class method here, sprite node with image named, and then we can just put in a string value of the name of the image. So our image is called space, so I'll put space in here. And one thing to keep in mind here is that I don't have to specify when I'm adding an image here, I don't have to specify this at 2x. If I just leave that out, then SpriteKit will automatically use the correct version. And I don't have to put PNG in there either. I can just put space and SpriteKit will work out the rest. So that is pretty handy. But now let's just get this displaying on the screen. So to do that, we're going to need to add it to our scene. And we should also perhaps position this to make sure that it's going to be positioned in the right spot. So our image is going to be drawn centered on the position of our sprite node. So if we want this to be drawn in the right spot, we need to center our graphic in the middle of the screen. So to do that, we can say background.position and set this to be a new CG point. So to create a CG point, we go CG point make. And then on our x-axis, we need to get the width of the scene here. So this is the class we're working in is our scene, and it has a size, and we've got size right here. So we can actually just use size dot width, but we need to get half of that. So we can multiply that by half, and then we can say size dot height and multiply that by a half as well. And so that's going to position our background in the middle of the scene. And then we just need to add our background to the scene. So we say self add child background. And we'll now have that background will now be a child of our scene. So when our scene is drawn, it will draw a background. So let's just check that that's working by running our project here, and we should hopefully see our background. Cool, so there we go, we've got our background there, which is looking nice, and we've got our hello world text over the top, and if I click, we get our spaceship showing up. So yeah, that's just been a quick look at how to get our images into our projects, and then also just another quick look at creating a sprite node there and positioning it. So in this video, I thought we would talk a little bit about coordinate systems. When we're working with games, we're going to be adding a lot of different nodes. We're going to be moving them around our scenes a lot, and just, having them interact with each other. And when we do that, we need to make sure that we understand how they're moving within the different coordinate systems that they are contained within. So I thought it's good if we make sure that we understand all that by playing around with the template project that we were looking at from the last video, and just adding a few different objects and stuff to it, a few different nodes. So here I've just running it so that we can see that we still have the spaceship like we had last time, moving up in the scene. And that's cool. So yeah, I guess maybe just to point out, our 0, 0 point at the moment is down in the bottom left hand corner here, and when we're adding the spaceship at the moment to the position of the click, but we can see that it's being centered on that position, and so then the points are going up on the y-axis. So as this is going up, its y location is increasing. So yeah, so I'll just point that out. But I think also to start, we should just talk about this this graphic that we've got here. As you can see here, it's not as big as it was appearing in the simulator, and that is because SpriteKit is assuming that this graphic is designed for a lower resolution display. So iPhones can have, the smaller standard resolution displays, so like with the old iPods and iPhone 4, the iPhone 3GS and whatnot. But then the new ones, since the iPhone 4 has the Retina display, so we need, if we're creating graphics for a Retina display, we need to have it at 2 times the resolution of a standard display. And then we need to tell SpriteKit that that is what's going on. So if we rename this graphic to be at 2x, that's going to tell SpriteKit that, hey, this is a graphic that's designed for Retina displays, so you should not scale it up and actually display it sort of at the resolution that it is. And so now we can see that our spaceship runs, looks a little bit more of a sensible size. So that's cool. But so what we want to do to that is we want to, I thought we could add some flame to the coming out of the back of the spaceship. So I've created a graphic, and I'm just going to add it here. So I'm going to go, oh no, I don't want a new file, sorry. So I'm going to go up here and add files to SpriteKit demo. And in my documents folder here, I've got flame. So yeah, we're going to add this guy. So here we can easily add him to the scene just by, after we've created our spaceship here, let's create a new thing, a new node called sk sprite node left flame, and I'm gonna go sk sprite node with image named flame, and I'm gonna set its position equals location. And for now, I'm just going to add it to the scene. So I'm going to go self add child left flame, just so that we can see what that does. So I've said that I want to add it to the same point where they click, and I want to add it to the scene. And when we run that, we should see that we get a spaceship that moves forward, and it's left underneath it the flame. So yeah. So that's happening, it's running underneath it because we're adding it before we're adding the spaceship, which I guess I didn't really point out is happening here. So yeah, because we're adding the left flame and then we're adding the sprite, which is the spaceship. But obviously we want the flame to move with the spaceship. So let's, instead of adding it to the scene, let's add it to sprite, which is the spaceship. And now let's see what happens. Okay, so when I add it here, we can see it moves with the ship, but it also does this weird thing where it's like way out of position now. And so the reason for that is that the position that we told the flame to be placed at is in relation to its parent's coordinate system. So it's taking into account the location of my click, and then it's like adding that to the position of the ship. So it's just like way out. So we're going to need to think a little bit about how we actually are going to position this guy if we're going to get it in the right spot. So here I've got a little bit of details on the graphics that we're working with at the moment. So we can see here the different pixel dimensions of the actual PNG files that I've created. So we could also should point out that when we're positioning them in the scene, they are being centered, and so that means that the coordinate system of the sprite is in the middle. So if I'm going to add the flame at 0, 0 to the spaceship, it's going to show up in the middle of the spaceship. We don't really want that. So what we actually want to do is we want to move it 24 pixels to the left and 174 pixels down on the y-axis. But we need to remember that if we put it there, then it's going to be centered. The flame is going to be centered there. So we need to move it down a further 44 to get it in the right spot so that it's going to show up there. So if we do a little bit of maths, we need to move it minus 24 on the x-axis, and then 174 plus 44 equals 218, so we need to move it to minus 218 on the y. But because these graphics are retina, we need to convert that into points, so we need to divide those values by 2 because those are the pixel dimensions. So that's going to give us minus 12 and minus 109. So how about we go ahead and do that to this guy? So instead of here putting location, let's go CG point make minus 12 and minus 109. And if I run that, I think I should see that my flame shows up in the correct spot. Okay, so yeah, that looks a little bit better. So now we've got a left flame coming out of the back of that spaceship, which is cool, but now we need to add another one. So under this guy, let's add a right flame. Let's go sprite node, right flame. Okay, sprite node with image named flame, same graphic, right flame dot position. Now I'm actually going to do this one a little bit different. So I'll just comment this out for now, and I'm just going to add this guy and say sprite add child right flame. And I'm going to talk a little bit about the anchor points. So We mentioned before that we can, things are being centered here. So the graphic's being centered in relation to the position, but we don't have to have it work that way if we want. We can change what's called the anchor point property, which is where is this in relation to the graphics. So the anchor point uses the unit coordinate system, where 0, 0 is at the bottom left and 1, 1 is at the far top right. So by default, our graphics are being set with an anchor point of 0.5, 0.5. So it's saying, put it in the middle. And we can see that, if we were to rotate this flame, it would sort of look like this. It would rotate sort of around this point. But we might want to rotate something and have it rotate around a different point, so we could change it. So if we change our anchor point of our graphic to be sort of at the top here, we still want it sort of centered horizontally, but vertically we want it at the top. So if we change it to 0.51, then that would mean that we don't have to actually take into account that 44 pixels that we talked about before. We could just position it straight there. So, and then that's going to give us our new values of ending up with minus 87 that we can see there after we take this into account, but we ignore that bit because we're just going to position it straight there. So we want 12 to the right and minus 87 for this guy. So position equals CG point 12 and minus 87. But in order to make that work, we also need to set the anchor point. So let's go right flame dot anchor point equals CG point make. So we still want it halfway across on the horizontal, but we want it all the way at the top on the y-axis. And when I run this guy, hopefully we should see that we've got two flames coming out of the back of our ship that are in the positions that we expect them to be. Yeah, there we go. And they're moving along with the ship because they've been added to the ship's node. So yeah, I know that was sort of a bit of a bit to go through, but I guess it's just making sure that we sort of understand how all the coordinate systems work. So I'd really recommend just going in and playing around with that some more, just sort of adding a bunch of different nodes, creating a whole bunch of hierarchy of different nodes added to more nodes and moving them around, rotating them, seeing how that affects each other, just so that you can get a really good handle on how the coordinate system stuff works. We've had a little bit of a chat about anchor points, but I want to go into them in a little bit more detail, just in case there's any sort of confusion for you in regards to anchor points. So whenever we're working with a sprite node, we need to consider how is the image of that node going to be positioned relative to the actual position of the node. And that is determined by the anchor point. So by default, a sprite node has its anchor point set to be 0.5 by 0.5, and that means that the image is going to be centered on the location of the node. So if we just run this project here, at the moment I'm just working with the standard SpriteKit template project, but I have renamed our spaceship here to be at 2x, so it's a little bit smaller. But we should see our spaceship comes up and it will rotate. But we are adding our spaceship. We're setting the node when we create it to be the position of the click. So as soon as I click, our sprite node now has its position set to that location. And we can see that the image was centered on that location, and also the rotation of the image runs around that point. So where we put our anchor point is important, especially when we're considering rotation here. So if I were to change the anchor point, and what I'm going to do is open up this image here just so we could see it, see the full dimensions here. We can see that there's this kind of transparent section down here. So if I was to set the anchor point to be 0, 0, then our image would be positioned relative to the position of the node as though the position is down here. Likewise, if I was to set it to 1, 1, then the image would be positioned relative to this point here. So what we're going to do is just jump back into our game scene here and update the anchor point of our spaceship. So we'll say sprite .anchor point equals CG.0. So this CG.0 is just a nice little convenience method that will give us a CG point that has the value 0, 0. So we should now see our spaceship rotating quite differently to how it was before. So remember, wherever I click, that's where we position our node, and now we can see that our spaceship is rotating around that point in a very different way, and our image has also been positioned no longer centered on that point. But if we perhaps wanted to rotate around a specific point in our image, we would need to be able to calculate what that point should be, or what we should set our anchor point to. So what I want to do is, we've got this kind of little circly thing here as part of the graphic. I want to set our anchor point so that our image is positioned such that this little circle thing is centered on the position of the node, and so we should rotate around this as well. So to work this out, we can see here our image dimensions is 394 pixels by 347 pixels. But we need to work out how far do we need to move on the x-axis and on the y-axis to get to this point. So if I were to drag this out, it's going to give us some dimensions here. And we can see that we need to move roughly 279 by 127 pixels. But we need to convert this into this unit coordinate system. So we need to convert this into a value between 0 and 1 for each axis. So we can do that simply enough by, in this case, taking 279 and dividing that by 394. So if I get the calculator out here, I can say 279 divided by 394. And I get this value of 0.7 here. So we'll use that. So we'll set our anchor point here to a new CG point by going CG point make. And I'll say 0.7. And then if we jump back in here, we know that we needed 127 on the y, and we need to divide that by 347. So 127 divided by 347, and we get 0.36 or thereabouts. So we'll put that in here as well, so 0.36. And now we should hopefully see when we run this that our ship will be rotating around that little circle that was part of the graphic. So I'll click here, and we can now see that our ship is centered on that point. So we seem to have worked that out correctly, so that's good. But one thing to keep in mind when you're working with your anchor points is, ideally you want to have some sort of standard system that you use throughout your game, because otherwise you're going to tend to make your code a little bit confusing. If you're working with lots of different nodes and they all have different anchor points, positioning them in the right spot can become a little bit challenging, or you're going to have to be constantly doing these calculations in order to take that anchor point into account. So sometimes it's best if you just kind of decide, okay, I'm going to keep all my sprite nodes to be centered on 0.5, 0.5 for the anchor points, or maybe positioning them at 0, 0, particularly if you're sort of using some sort of tile-based system. It might be easier to work with them that way. But it's definitely worth considering coming up with some sort of convention to use for your anchor points for your games. So that was just a little bit of a closer look at anchor points. Hopefully by doing those little examples there, you've sort of maybe got a better picture of how adjusting the anchor point changes where our actual images are drawn when we're drawing our sprite nodes. In this video, I thought it would be a good idea if we had a quick chat about game loops. If you're new to game development, it could be a concept that you haven't really come across before, and it's worth having a good understanding of it just so that you can think in terms of the game loop when you're doing your coding. So if you think about how traditional animation works, where you have a series of images that you play one after the other to maybe produce an animation of a person running, for example, When we're displaying stuff in our games, that's working the exact same way, but each of those frames is being set up and eventually rendered by the game loop. So here I've got an example of a very, very basic game loop that would really run as fast as it can. But we can see that it's going off and doing a bunch of different processing things to really update the state of the game as it is at that point in time. So yeah, that's something to keep in mind when we're coding, that we need to think of it in terms of how is the game represented right now at this point in time, and how should I respond to that. Luckily, we don't have to write the game loop ourselves because SpriteKit has taken care of that for us. And instead of having to write a method to handle all of that, we can just hook into various methods that SpriteKit is calling for us once every frame. So I've taken this graphic from the Apple documentation, and I'll include a link to it because it's worth having a bit of a read of some of this stuff. But I thought we'd just go through and see what's happening in SpriteKit once every frame. So first up, we can see that it's calling the update method, and all of these methods that get called happen on your scenes, by the way. So we can hook into these methods in our SKScene classes that we implement. So in the update method, that is a good spot to do stuff like processing input. So say the player touches the screen and we want to have our character jump, that would be a good place to put that code. Or you might want to do things like our AI for our enemies and stuff in here. After all of that's happened, SpriteKit is going to go off and process the different actions. So in our previous videos, we saw how we could set up actions to make the spaceship move around. That's all happening here. And after it's done with that, it's going to call the didEvaluateActions method. So that's going to give us a chance to respond and do anything that we need to do that we want to happen after the actions have been performed, but before the physics simulation has happened. So here is where SpriteKit is going to go off and do all the physics stuff. It's going to move the nodes around, have them bounce into each other, stuff like that. And then it's going to let us know that all of that is done by calling the didSimulatePhysics method. So in there, we might want to respond to different collision events that have occurred. We might want to update scoring and stuff like that. And after we've done all of that, SpriteKit is going to go off and render all of that stuff to the screen. So yeah, I think it's not a particularly complex concept or anything, but it is a good idea to keep that stuff in mind. And one more thing is that if we think about the performance of our game, if we want to be running at 60 frames per second, which is usually our target frame rate, then we need to make sure that any code that we write is going to be able to be run in 1/60th of a second or less. Because if it takes longer than that, then our frame rate is going to suffer and it's going to drop. So that is an important thing to keep in mind as well. So yeah, I think that was just a quick summary of how the game loop works, and it's worth keeping that stuff in mind when you're coding your games. In this video, I want to have a really quick chat about actions. We're going to be using actions quite a lot as we move forward, and so I thought it might be a good idea to just kind of clarify what an action is and kind of why we might want to use them. So when we're developing a game, we want stuff to be moving around on screen, so we need to sort of be animating stuff, and we need to sort of move things around. So I guess one way that we can sort of do that is by using these actions, because an action allows us to change the properties of a node, and we can generally do that over time, so we don't have to set the properties ourselves every single frame or sort of continually be updating things. We can kind of set up an action to do it for us and say, okay, move this object to this location over this amount of time. So actions allow us to kind of set up these instructions that we can give to our nodes, and then we can just run these actions against our nodes. So generally what we'll do is we'll set up an action by creating an instance of one, and then we will find some node that we want to run the action against, and we'll use this run action method on the node and pass in the action that we want to run. So far we've seen how this rotate by angle action works, because we've seen our ship rotating around. And so just looking at this one, we can see that it's currently set up to tell the spaceship to rotate by pi radians, and it's doing that rotation over the duration of 1 second. But our ship continues to rotate because this action has been wrapped in another action, which is a repeat forever action. So every time that 1 second is up, it will continue on and run the action again. So let's just do another declaration here, and we'll create a new action. We'll see maybe some of the other types of actions that we can use. So we'll just declare an action here, new action. And generally the way that we create an action is to access the class skAction, and then find one of the class methods to actually return us an instance of an action. So here I've got sort of remove from parent, so that can we can use that to remove a node from its parent, so it will be removed from the tree and cleaned up. We've seen this repeat forever action, or we could say repeat a certain number of times. We could resize a node by using one of these resize actions. What else have we got? We've got scale, which is similar to resize, I guess, but we can scale it over some sort of time or by a certain amount. Sequences are interesting. Sequences allow us to group a number of actions together and run them one after the other. We've got set texture here. We've also got a group. So a group is similar to a sequence, but all of the actions will be run at the same time. We've got perform selector action, so that will allow us to actually run a method. So go off and run some code. We could play a sound. We've got animate actions that we can pass in a number of different textures and animate between them. So there's all sorts of different actions that we can create, and we'll be covering a lot of them as we go through the course. But let's just create one more here. I'm going to create a scale action. So I'm going to say that I want to scale by, say, 2 over a duration of 1 second. So I want it to double in size every second. And then I'm going to run that here against our sprites. So I'll say, I'm just going to comment this stuff out first though. So let's say sprite run action. And there's a couple of different options that we have here for running an action. We can run it with a completion. So what that means is that we can, after this action's finished, we can run a block of code. So that can be handy sometimes. And we can give our action a key so that we can find it again later on our node. We can look up actions for a particular key and then sort of stop them from running. But for the moment, we just want to run this once. So we'll just say run a new action. So pass in our action there. And if we get this going, we should see that our ship will scale by 2, and it will do that over 1 second. Cool, so there we can see we don't have that repeat forever action in there, so it scales up and then it just stops. So we can see that that's working nicely. So yeah, that's just setting up a new action there. One thing to note about actions is that they are stateless. So that means that you can run the same instance of an action against multiple nodes without sort of having to worry about any sort of conflict. So if I was to run this scale by action on a second node, and sort of maybe I did that a few frames later, they would sort of scale individually at their own rates. It wouldn't sort of conflict, or this action is not holding some sort of current scale value inside of it that would conflict between the two nodes. So that can be quite useful if you just want to create one instance of an action that, say, maybe move some things around and then run that against a whole bunch of different nodes at the same time. It can be sort of more efficient to do things that way. So that's one thing to keep in mind. So yeah, I guess that's a pretty brief overview of actions. We are going to be using them quite a lot as we move forward, so you'll sort of see them in action, so to speak, as we go along. But I just wanted to sort of do another bit of an overview there and just sort of see how we can create an action and run it against a node. I thought it might be worth briefly talking about the diagnostic information that we have as part of SpriteKit. So I guess when we're thinking about the performance of our game, it's good to have something to check in on that, to have some feedback. So we can see that really the key piece of information that we're running on is the frame rate. So is our game running at 60 frames per second, which is probably going to be our target frame rate. So, I mean, that information is provided for us, and we can see here it's hovering around that. And if you may notice that if you add a whole bunch of nodes, you can see the node count going up here, that the frame rate drops. Now, the reason that that's happening is because this is just the simulator. So the simulator doesn't benefit from the hardware acceleration that you get when you're running on the actual device. So if you're seeing your frame rate drop, your computer might be faster than mine, so you might not have the same problem. But if you do see the frame rate drop in the simulator, probably don't worry about it too much. So always make sure that you're checking on your device. That's where you want to be checking for your performance. And yeah, making sure that it's all running smoothly on there. But I mean, the reason that we want to have this here most of the time is because if we add a new feature to the game and suddenly the frame rate drops, that's probably a good indicator to us that maybe we should rethink about that feature that we just added. Maybe that's something that we need to look at optimizing or doing in a different way. So by constantly checking in with the frame rate on a regular basis, it's a good idea to sort of keep track of some of that stuff. Now I've also turned on here the draw count, which you can do by on your SK view, just setting shows draw count to yes. It's always probably a good idea to have more information. If we can have more information, why not? So turning on the draw count, that's letting us know how many passes SpriteKit's having to do each time it builds up a frame to display on the screen. So we can see that it doesn't match the number of nodes exactly, and that's the reason for that is because these two flame graphics are the same graphics, so it can just do both of those in the same draw pass. So obviously the fewer draw calls that it has to do, the better performance is going to be. So there are some techniques that we can use to actually keep that draw count down, like using sprite sheets or atlases, which we'll sort of get into in a later video. But yeah, I guess I just wanted to point some of those things out and so that we can sort of keep an eye on our frame rate and make sure that our games are running fast.